12.2a is on the fundamental counting principle. So sometimes in math, we want to be able to count the number of ways an event can happen. So the question becomes, how can you count or figure out the number of possibilities for any given situation? Let's look at an example. Say you own a small deli. You offer 4 types of meat, for example, ham, turkey, roast beef, and pastrami, and 3 types of bread, white, wheat, and rye. How many choices do your customers have for a sandwich? So one method of figuring this out is just to list all of the possibilities, and that's this diagram we have right here. These are all of the different possible sandwiches you could make from this combination of meat and bread, and there are 12 different sandwiches. So that's one way to figure this out. However, the more options we have, the longer it would take for us to list all of our possibilities. So say we had 5 types of meat and 6 types of bread, and we added cheese into the mix. It would take us a lot longer to list out all of these combinations. So we will need a shortcut, and that is where our fundamental counting principle comes in. Based on the fundamental counting principle, you would take your 4 choices for meat, your 3 choices for bread, and multiply them together. Well, 3 times 4 tells us that there are 12 possible sandwiches based off of our 4 choices for meat and 3 choices for bread. So we got the same answer, we just got it a lot faster, and that is what the fundamental counting principle does. Let's look at a couple more situations. So letter B, we want to calculate the number of possibilities using the fundamental counting principle. So at a restaurant, you have a choice of 8 different entrees, so 8 different main courses, 2 different salads, 12 different drinks, 6 different desserts, and we want to know how many different dinners consisting of 1 salad, 1 entree, 1 drink, and 1 dessert can you choose? Well, based on that fundamental counting principle, we're just going to multiply. 8 entrees times 2 salads times 12 drinks times 6 desserts. When we multiply that together, that tells us that there are 1,152 different dinners you could order at this restaurant. Okay, and that would be the number of possibilities in this particular situation. Let's look at a couple more examples. How many different phone numbers are possible if the first digit cannot be 0 or 1, right? So when we're thinking about this, if your first digit cannot be 0 or 1, the only digits we have are the digits 0 to 9. So the digits it could be would be 2, 3, 4, 5, 6, 7, 8, and 9. Well, that leaves us with 8 different possibilities, or 8 options for those for that first digit, right? We're just limiting that first digit. So I'm going to draw a little picture here. We have 7 different numbers, right, because it's a 7-digit phone number. We decided we have 8 options for the first number. And then for the other 6, well, the other 6 could be any number from 0 to 9. So we have 10 options for those. So based on our fundamental counting principle, we're just going to multiply all of our options together. So we have 8 times 10 times 10 times 10 times 10 times 10. Well, we could write this as 8 times 10 to the 6th power, which is 8 million different phone numbers. Okay. Number 3, how many ways can you arrange the letters in the word bad? Well, this is, again, somewhere where we could list out all of the different possibilities, right? It wouldn't take us too long. However, we could just multiply. Right, we have 3 different spots. So for that first option, right, that first letter, we have 3 options. It could be B, A, or D. Well, we used one of those letters for the first spot. So then when we get to the second spot, we only have 2 options left. Right? We would only have 2 letters left. And then that last spot, it'd be whatever the third and last letter is. So if we take 3 times 2 times 1, that tells us there are 6 ways to arrange the letters in the word bad. Okay. Letter C, we want to talk about this new mathematical operation called a factorial. So a factorial is the product of all of the integers or whole numbers from 1 to n. Factorial is denoted by an exclamation point. So if you see something that looks like this, it's read as n factorial. So n exclamation point, we read that as n factorial. So let's look at a couple of these. 0 factorial is 1. We're not going to get into the mathematical reasoning behind that, but just know 0 factorial is 1. 1 factorial is telling us we're taking just the number 1. Right? So 1 factorial is just 1. 4 factorial is telling us we're taking the numbers from 4 to 1 and multiplying them together. So 4 times 3 times 2 times 1. And if we multiply all of those together, we get 24. 7 factorial tells us we're taking the numbers from 7 to 1 and multiplying them together. 7 times 6 times 5 times 4 times 3 times 2 times 1. And if we multiply all of those together, we get 5,040. So factorial is just this new mathematical operation. So we want to try calculating some things using a factorial. And how many ways can you arrange the letters in the word math? Well, math has 4 letters, okay? 4 letters, so we can arrange them in 4 factorial ways. So that would be our 4 times 3 times 2 times 1, which gives us 24 ways to arrange these letters. This would be a good time to pause and try number 2 for yourself. And how many ways can you arrange 5 photos on a shelf? Well, this would be 5 factorial. So it would really just be 4 factorial times 5. But 5 times 4 times 3 times 2 times 1 would be 120. So there are 120 ways that you can arrange 5 photos on a shelf. So this is our factorial. Tomorrow in class, we're actually going to look at how we can type a factorial into our calculators. But 12.2a, again, is just on different ways to figure out how many possibilities or count the number of possibilities of any given situation. And basically, we're just using multiplication to figure that out.